that the average density of Saturn is less than the density of water.
In the vast depths of our solar system, a celestial enigma is unfolding before our very eyes. For centuries, Saturn has captivated humanity with its breathtaking beauty and cosmic allure. Its rings are dazzling proof of the marvels of our universe.
You will descend down to the center of the planet.
But now, a dark shadow looms over this gas giant, a shadow that heralds an unsettling metamorphosis. As the scientific community races against time to decipher the signs of change, we unveil a truth that may alter our very perception of Saturn and its place in the cosmos. So join us on this electrifying journey as we unravel the secrets of Saturn's transformation.
If you scoop out a piece of Saturn, it will float on a puddle of water or in an ocean, it doesn't matter.
Saturn's early discovery. Saturn, the majestic giant of our solar system, has held a spellbinding allure for scientists and stargazers ever since it was first spotted. It occupies a unique spot in our cosmic curiosity. While it hasn't been graced by human footprints like Mars, it remains a favored celestial subject for astronomers. Remarkably, humankind has amassed a trove of knowledge about this ringed wonder. Its enigmas, from its shifting temperatures to its magnetic field and lunar companions, consistently boggle our minds. As the sixth planet from the Sun and the second largest in our cosmic neighborhood, Saturn assumes a prime role in our galactic arena. In the year 1610, the trailblazing astronomer Galileo pointed his telescope toward planet Saturn. His initial observations perplexingly revealed what seemed to be ears or arms on either side of the planet, a misinterpretation of the iconic rings that encircle it. Galileo's telescope could only unveil a fraction of Saturn's true grandeur. Nevertheless, his endeavors paved the way for the wealth of knowledge we now possess. In 1659, a Dutch astronomer named Christian Huygens, armed with a more potent telescope, turned his gaze to Saturn. To his astonishment, he unveiled the intricate ring system encircling the planet. Not content with this revelation, Huygens also laid eyes on Titan, Saturn's largest moon, further contributing to our burgeoning celestial comprehension. In 1675, yet another stargazer, Cassini, made a pivotal discovery. He found a gap amidst Saturn's rings, now dubbed the Cassini division, creating a distinct divide. As time marched forward, Saturn's exploration persisted, unearthing fresh revelations. Decades and centuries witnessed the unveiling of new layers of knowledge, enriching our understanding of this exceptional planet and bequeathing a substantial legacy of discoveries for posterity. Saturn, the cosmic giant. Interestingly, in the year 1979, a remarkable moment unfolded when the Pioneer 11 spacecraft offered humanity its inaugural up-close snapshots of Saturn, igniting our ongoing quest to unravel the mysteries of this cosmic giant. However, it wasn't until the Cassini mission arrived in 2004 that scientists could truly peel back the layers of this enigmatic ringed world. As we persist in exploring Saturn, it occasionally grants us fleeting glimpses of hidden enigmas, reminding us of the vast unknowns that still develop its intricate essence. Saturn, standing as the second largest planet in our solar system after Jupiter, cradles a core that's roughly half the size of its radius, bearing a mass that dwarfs Earth by 12 to 20 times. Astonishingly, if you had a container expansive enough, Saturn would merrily float on water. This peculiar phenomenon results from its astonishingly low density, measuring just 0.687 grams per cubic centimeter, rendering it the least dense of all our cosmic neighbors. Yet, Saturn's uniqueness doesn't cease there. While most other planets in the solar system boast near spherical shapes, Saturn flaunts its distinctiveness by being the most oblate of the bunch. Completing its orbit in a brisk 10.5 hours, it twirls with remarkable speed. This swift rotation causes the gas giant to swell at its equator while somewhat flattening at its poles, giving it an oblate appearance. Saturn's grandeur knows no bounds, with a diameter at its equator stretching across about 75,000 miles and a distance from pole to pole extending around 68,000 miles. Its iconic golden and yellow bands, observable from Earth, owe their existence to the supersonic winds whipping through the upper atmosphere at an astonishing speed of 1,100 miles per hour. These atmospheric ribbons contribute to Saturn's celestial allure, making it a captivating cosmic gem in our celestial neighbor. Within Saturn's dynamic atmosphere, to reveal the true treasure of Saturn, the Cassini Probe, a tribute to the revered astronomer Cassini for his groundbreaking work on Saturn, embarked on an ambitious mission to demystify the intriguing aspects of the ringed planet. Crafted through a collaborative effort involving the National Aeronautics and Space Administration, the European Space Agency, and the Italian Space Agency, this robotic spacecraft stood as a pinnacle of human innovation. On the historic date of July 1, 2004, Cassini marked a significant milestone by becoming the fourth spacecraft to reach Saturn's vicinity. Diverging from its predecessors that merely conducted flybys, Cassini blazed a new trail by daringly plunging deep into Saturn's atmosphere, revealing a treasure trove of previously concealed secrets. This intrepid explorer remained dedicated to its mission for an astonishing 13 Earth years, diligently amassing a treasure trove of priceless data. Its mission could have continued for another decade or so, if not for the depletion of fuel reserves. Nevertheless, Cassini's triumphant journey was far from futile. Before its final descent, the probe transmitted an astounding 453,000 images and a wealth of data from its versatile instruments, including spectrometers and magnetic sensors. This remarkable contribution significantly augmented our understanding of Saturn's resplendent rings and dynamic atmosphere. Additionally, it beamed vital insights about Saturn's magnetic field back to Earth, deepening our knowledge of this colossal gas giant. Intriguingly, among the most mesmerizing discoveries from Cassini's mission was the observation of Saturn's hexagonal storm, a hexagonal pattern encircling the planet's north pole, a phenomenon that continues to enthrall scientists and space enthusiasts alike. The Hexagon Storm. Meanwhile, for nearly a century, this mesmerizing hexagonal storm has adorned the surface of Saturn, casting a unique and easily observable pattern across the gas giant, whether you peer through a telescope or scan it with space probes. Its distinct hexagonal shape spans an astonishing 20,000 miles in diameter, earning its apt name. At first glance, this hexagonal spectacle might seem like a serene cloud formation, but it harbors a tempestuous secret. Deep within its core resides a colossal hurricane, dwarfing Earth's mightiest storms by a staggering 50-fold or more. This cosmic anomaly, where the hurricane and other vortexes in the vicinity converge, creates an intricate hexagonal jet stream, perpetuating this mesmerizing pattern. What's equally intriguing is the composition of particles within this hexagon, which starkly differs from its surroundings. Inside, a wealth of minuscule haze particles dominates, in stark contrast to the larger particles prevalent outside the hexagon's boundary. This discrepancy in particle sizes adds a layer of mystery to this already puzzling phenomenon. Perhaps the most astonishing revelation is that the hexagonal storm remains anchored in place, steadfastly tracking the planet's rotation. Unlike terrestrial weather systems that meander and transform, Saturn's hexagon maintains its unwavering position, leaving scientists and space enthusiasts alike in perpetual awe of this celestial enigma. Although the enduring enigma of the Hexagon Storm has long been a perplexing riddle for scientists, driving them to delve deeper into its mysteries. Recent studies have uncovered yet another layer of intrigue, a gradual shift in its color palette. The once familiar blue hue is gradually morphing into a captivating golden shade, a transformation that both fascinates and mystifies scientists. Is this a novel event in the storm's history, or has it occurred in the depths of cosmic time before, creating an astronomical déjà vu? This extraordinary hexagon storm, which challenges our conventional understanding, has graced Saturn's expanse for decades, perhaps even centuries. What's fascinating is that our awareness of this phenomenon only began when astronomers finally acquired the means to observe Saturn up close. Could this mesmerizing hexagon have been an enigmatic feature of the cosmos, unknown to us in eras past? If indeed it has ancient roots dating back centuries or more, it might hold secrets that transcend our current comprehension. There could be stories written in their ever-changing colors, tales woven within their geometric form that we may never fully decipher. The riddles within Saturn's hexagon. Delving into the depths of Saturn's mysteries, computer simulations step forward to elucidate the captivating riddle of its Hexagon Storm. The key to understanding this enigmatic formation lies in the transfer of heat, driven by the movement of fluids or gases within Saturn's atmosphere. These movements create atmospheric flows, giving birth to vast polar cyclones and eastward-bound jet patterns. When these elements converge in Saturn's upper atmosphere, they manifest as the striking hexagonal shape that graces our view. Scientific models suggest that Saturn's hexagonal storm endures due to its genesis deep within the planet. Yet this distinct storm remains a singular phenomenon, and scientists have not encountered a similar one elsewhere in the vast expanse of the universe. This renders Saturn's hexagon an immense cosmic puzzle that continues to captivate our imagination. Saturn, classified as a gas giant, earns its title from its predominantly composed hydrogen and helium. However, there's a fascinating twist to its composition. The tremendous pressure and temperature deep within Saturn's atmosphere cause most of its hydrogen to transform into liquid metal. As one ventures into Saturn's depths, the heat and pressure intensify, similar to the escalating geothermal experience as you delve into Earth's crust. Interestingly, Saturn stands apart as the sole planet boasting a hexagonal storm, even among its fellow gas giants. Meanwhile, within Saturn's depths, a fascinating transformation takes place. Scientists speculate that the immense pressure can convert hydrogen into precious diamonds, gently raining down into the planet's core. This extraordinary process isn't merely a gem-making show, it significantly contributes to Saturn's intriguing thermal behavior. The friction generated by this transformative journey is believed to be a key player in the planet's unique heat emissions. Astonishingly, Saturn radiates double the heat it receives from the Sun, distinguishing it as a celestial anomaly unlike any other in our solar neighborhood. Saturn Spokes. However, in the depths of data beamed back by Voyager, scientists stumbled upon a strange enigma of perplexing spokes streaking across Saturn's majestic rings. But, during the Cassini mission, a puzzling twist unveiled itself. The once ghostly spokes that had haunted Saturn's rings seemed to have mysteriously vanished into thin air, deepening the cosmic conundrum. Upon closer scrutiny, a peculiar pattern came to light. These enigmatic streaks exhibited a dark demeanor when viewed from above. Yet, as if by some cosmic magic, they transformed into luminous ribbons when observed from below, similar to celestial chameleons adapting to their surroundings. The root cause of these elusive streaks continues to evade researchers, but a tantalizing hypothesis emerges. These spokes may originate from dust particles within the rings, which emancipate themselves from icy chunks floating freely above the icy boulders. Saturn's magnetic field likely plays the puppeteer in this cosmic theater. When the solar wind interacts with Saturn's magnetic aura, it ignites an electrically charged environment. This celestial ballet influences the behavior of charged dust particles, coaxing them temporarily to coalesce and create dense patches within the celestial rings. To add to the intrigue, Saturn boasts its quartet of seasons, each lasting roughly 7 Earth years. Just as our planet experiences seasonal transformations, Saturn dons its cosmic attire, setting the stage for these mysterious spokes to reappear during the planet's spring and fall, offering a captivating celestial performance in the grand cosmic theater. Now it's time for today's subscriber pick. In the quiet expanse of our solar system, where the planets have long seemed like steady celestial beacons, a shocking revelation emerged. Saturn, the magnificent ringed giant, was undergoing an unprecedented transformation, leaving scientists perplexed and concerned. For centuries, Saturn's iconic rings had encircled the planet, a symbol of cosmic constancy. But now, inexplicable changes were unfolding. Telescopes and spacecraft bore witness to dramatic shifts in the planet's famous rings. The once pristine bands, composed of icy particles and rocky debris, had developed strange anomalies. Gaps appeared where none had existed before, while new rings formed, like wrinkles on the planet's colossal visage. As astronomers raced to analyze the data pouring in from the Cassini spacecraft and ground-based observatories, one thing became clear. Saturn's transformation wasn't limited to its rings. The planet's atmosphere was experiencing turbulence as well. Mysterious storms erupted in its gaseous layers, resembling cosmic tempests of otherworldly origin. These unexpected changes were not merely a scientific curiosity, they carried ominous implications. Planetary scientists realized that Saturn's evolving state might disrupt the intricate dance of celestial bodies in the solar system. As they delved deeper into the enigma, they pondered whether human activities, such as space exploration or climate change on Earth, might be playing a role. Saturn's metamorphosis had evolved into an enigmatic cosmic puzzle, a profound mystery that both fascinated and concerned the scientific community. Indeed, scientists are stumped. Saturn is changing and it's not good. What do you think might cause this depletion in Saturn? Please, do share your thoughts on this cryptic matter in the comments below. Saturn's magnetic field and radio wave. Beneath Saturn's scorching outer layers, a captivating secret is concealed within its magnetic field. A planet's magnetic field is not just a mundane concept. It's like a celestial storyteller, whispering details about the planet's rhythms and cycles. This magnetic tale is woven by the dynamo effect, a result of the planet's internal churn and rotation stirring up the liquid metal at its core, giving birth to powerful currents of energy that manifest as magnetic fields. In this symphonic cosmic orchestra, Saturn performs an extraordinary solo. Typically, a magnetic field's rotation aligns with a planet's day cycle, completing one rotation to mark one day. But Saturn gracefully dances to its unique tune. Its magnetic field tilts at an angle that defies conventional wisdom, challenging the norm. It shouldn't remain as strong and oriented as it is. Saturn's magnetic field boasts a staggering strength, a colossal 580 times that of Earth's magnetic field. A mystery that leaves scientists humbled and curious about its origins and lasting power. As scientists delve deeper into this cosmic enigma, they grapple with understanding Saturn's day cycle. Deciphering the duration of Saturn's rotation and its magnetic ballet requires meticulous study and adds another layer to the rich tapestry of Saturn's mysteries, further fueling our cosmic curiosity. Beyond Saturn's magnetic fields, scientists delved into the captivating realm of its radio waves. Their explorations led to a remarkable discovery. Saturn emitted radio waves that followed a rhythmic dance, oscillating in strength with a fascinating pattern. This pulsating pattern wasn't haphazard, it adhered to a distinct timing. Researchers observed that higher levels of radiation surged every 11 hours, a finding that neatly aligned with the estimate derived from Voyager 2's data. The Voyager probe, in its exploratory mission, had meticulously measured Saturn's day cycle, estimating it to be around 10 hours and 40 minutes. Surprisingly, this newfound 11-hour day became the official standard, solidifying our understanding of Saturn's rhythm. However, Cassini, the diligent observer, added a layer of complexity to this understanding. Over its 13-year mission, Cassini discovered that Saturn's rotation speed wasn't constant. It exhibited unpredictable variations, with the time taken to complete one day sporadically expanding and contracting, introducing a perplexing phenomenon into the mix. This peculiar behavior baffled the scientific community, sparking a divide in beliefs. Some experts staunchly doubted that Saturn's behavior could be naturally so erratic. Instead, they embarked on an in-depth investigation, centering their hypothesis on something within Saturn's complex atmosphere being the driving force behind this enigmatic phenomenon. However, conclusive evidence remained elusive, and the debate persisted. Were these experts correct in their assumption, or was Saturn hiding an even deeper secret? At present, the available data cannot definitively confirm or refute their theory. Nevertheless, it's crucial to note that these deviations were relatively minor, hovering around a mere plus or minus 1%. In essence, the 11-hour day assumption still largely held its ground, underlining the mystery that Saturn continues to present to astronomers, captivating their curiosity with its intricacies. The Cassini Probe embarked on a captivating mission to unravel Saturn's secrets, and it didn't disappoint. Saturn, with its unusual heat pattern, broke away from the typical heat sources we know. Its heat wasn't what you'd expect, defying norms and sparking curiosity. Adding to the allure were Saturn's auroras, a mesmerizing puzzle. Unlike Earth's auroras fueled by solar flares, Saturn's auroras had an independent spirit. dancing in the sky, unaffected by solar winds. What fueled this spectacle was equally exceptional. Electrically charged particles from Saturn's rings and moons, not the Sun, came together to create this stunning phenomenon, a rare occurrence in our solar system. Scientists found this electrifying display intriguing, speculating about its link to Saturn's extreme temperatures, adding another layer to the planet's mystique. And then there were Saturn's magnificent rings, a true gem in our solar system's collection. They boasted the grandest title, a celestial jewelry box. The rings, named in order of discovery, revealed the splendor of Saturn. The B ring, the C ring, followed by the D, E, F, and G rings, each adding to the magic of this ringed wonder. The Saturn's Rings. Meanwhile, many giant planets in our solar system boast their rings. Saturn's rings steal the spotlight, elegantly adorning the planet's equator. Imagine this. The journey of these rings begins around 4,300 miles from Saturn's core, stretching out to an astonishing distance. As named earlier, take the E-ring, for instance. It sprawls an astounding range from approximately 75,000 to 260,000 miles. To make this vastness relatable, envision a road spanning the entire length of Saturn's E-ring, from its outer wisps to the inner boundary. Traveling at a constant speed of 100 miles per hour, it would take over 2.5 months to traverse from one end to the other. Let's not overlook the Phoebe ring, adding to Saturn's celestial allure. This ring stretches approximately 100 to 270 times the radius of Saturn, mirroring the planet's distinctive shape. Saturn's rings are a mesmerizing sight, renowned for their remarkable flatness. In-depth investigations have disclosed that in certain regions, these rings can puff up to about 0.6 miles in thickness. However, the main spectacle lies in their astonishing thinness, with the primary rings measuring a mere 32 feet thick. What deepens the fascination is the diversity among Saturn's ring particles. Scientists are literally stumped. Saturn is changing before our very eyes, and it's not good. It's like a cosmic buffet, ranging from tiny icy grains resembling specks of dust to substantial fragments similar to the size of houses. And here's the kicker. There are even a few extraordinary particles that defy the norm, soaring to dimensions that rival mountains. Then, you'd want to know, how did these majestic rings form in the first place? Formation of Saturn's rings. Within Saturn's captivating rings, composed primarily of pristine water ice, an intricate celestial ballet unfolds. This cosmic performance hinges on a delicate balance between two opposing cosmic forces. On one hand, Saturn's colossal gravitational pull persistently tugs at the ring particles, beckoning them toward the planet's embrace. On the other hand, these tiny particles are propelled outward into the vast cosmic stage by their orbital velocity. It's a mesmerizing interplay of cosmic physics. One of the most profound enigmas surrounding these magnificent rings is their origin story. For over 90% of Saturn's long history, these striking features didn't grace its presence. So, when and how did they come into existence? One theory proposes that these rings emerged later in Saturn's history, possibly the result of colossal collisions between small, icy moons that once orbited the gas giant. Such impacts might have been triggered by the gravitational tugs of wandering asteroids or comets, setting the stage for this cosmic spectacle. Intriguingly, a study in 2016 introduced another captivating notion. It suggests that Saturn's rings might be the ethereal remnants of dwarf planets that met their celestial fate in the distant past. These enigmatic rings could serve as the cosmic legacy of these celestial bodies, now gracefully encircling Saturn. Alternatively, it might have been a colossal collision that gave birth to these rings. Speculations surround a potential moon called Chrysalis, believed to have existed before Saturn's rings formed. Computer simulations propose that Chrysalis, similar in size to Saturn's third-largest moon, Iapetus, could have played a catalytic role in the creation of Saturn's celestial jewelry box. Moreover, the ever-shifting angles at which we observe Saturn's rings might be a consequence of its gravitational interactions with distant Neptune. These interactions caused Saturn's axis to tilt and wobble in synchrony with Neptune's orbit. However, in the grand celestial theater, the cosmic dance between Saturn's moon Titan and the ill-fated Chrysalis is a mesmerizing and timeless tale. While Titan engages in an energetic gravitational ballet, gracefully distancing itself from Saturn, our own moon follows a more leisurely choreography. But around 100 to 200 million years ago, a celestial symphony took center stage. Titan and Chrysalis found themselves in a celestial resonance, a gravitational duet that altered their fates. As Titan waltzed outward, its gravitational influence took on the role of a cosmic disruptor. Chrysalis, once in a stable orbit, was drawn closer to Saturn, drawn irresistibly into the mighty gas giant's gravitational embrace. In a dramatic crescendo, almost 99% of Chrysalis succumbed, merging with Saturn's colossal bulk. But the indomitable 1% persisted, enduring the celestial struggle, leaving behind the awe-inspiring ring system that now graces Saturn's celestial expanse. Depletion of Saturn's rings. Intriguingly, in a recent and riveting scientific study, a captivating story about Saturn's rings has come to light. These celestial treasures, often regarded as timeless, bear the relatively youthful age of approximately 100 to 400 million years. However, the fate that awaits them is one of gradual dissolution, like a grand masterpiece fading into history. The Sun, a celestial marvel of incredible influence, plays a central role in this narrative. In the course of another 100 million years or so, Saturn's majestic rings will ultimately yield to the Sun's relentless sway. The Sun, with its ceaseless radiation and occasional bursts of plasma triggered by space rock impacts, collaborates to whittle away Saturn's iconic rings. The drama intensifies when Saturn's rings experience electrifying transformations. Dust particles within them become electrically charged and restless. At these moments, they find themselves drawn to Saturn's magnetic field, an invisible force that inevitably pulls them towards the gas giant's upper atmosphere. Adding an extra layer of fascination is Saturn's cosmic dance with its rings around the Sun. This graceful waltz is not without its influence, as its tilt constantly changes the amount of radiation the inner ring layers receive, affecting the intensity of the icy ring rain. Recent revelations from NASA have uncovered a stunning reality. Saturn's magnificent ring system is vanishing at an astonishing pace. Every half hour, it loses a staggering volume of water equivalent to an Olympic swimming pool. This loss results from the enigmatic phenomenon known as ring rain, a spectacular spectacle in its own right. This continuous deluge, comprising around 6,000 pounds of icy particles previously bathed in solar ultraviolet radiation, gracefully descends onto the planet. As these particles embark on their atmospheric journey, they exchange energy with their surroundings through collisions with other particles, contributing to Saturn's atmospheric heating. This phenomenon might even be responsible for the luminous bands adorning Saturn's northern and southern hemispheres, adding another layer of enchantment to the story of Saturn's ethereal rings. Saturn's celestial wonders extend beyond its magnificent rings to a mesmerizing phenomenon: moon rain. Enceladus, one of Saturn's moons, takes center stage in this cosmic spectacle. It vents jets of water ice from its hidden subterranean ocean into the vastness of space. These tiny ice particles embark on a celestial journey, influenced by the cosmic forces at play. Their destination? Saturn's colossal atmosphere. The moon rain phenomenon is a cosmic cocktail, a blend of exotic chemicals. Saturn's ring rain, a complex mix, includes organic compounds such as water, butane, propane, methane, ammonia, carbon monoxide, carbon dioxide, and molecular nitrogen. This intriguing mixture holds the potential to transform the composition of Saturn's atmosphere over time, affecting oxygen and carbon levels. While these changes won't turn Saturn into a hospitable planet for life as we know it, the real fascination lies with Saturn's moons. Enceladus, with its subsurface ocean and enigmatic emissions, fuels the imaginations of scientists who ponder the possibility of life beyond Earth in the far reaches of our solar system. It's a reminder that even in the most inhospitable of environments, the potential for extraordinary discoveries and life's mysteries still lingers. Saturn's moons. Saturn, the undisputed king of moons in our solar system, recently revealed an astonishing secret. 62 new satellites gracefully orbiting the ringed giant, adding to a staggering total of 145 moons. But within this celestial menagerie, two moons, Titan and Enceladus, have captured the imagination of the scientific community. Titan stands out with its thick atmosphere, making it more akin to a planet than a moon. This atmosphere holds an abundance of organic molecules, including complex hydrocarbons. These hydrocarbons, found in everyday things like gasoline, serve as potential building blocks for life, sparking the tantalizing idea of life forms evolving on this enigmatic moon. On the other hand, Enceladus boasts a different allure. Deep beneath its icy surface lies a hidden ocean of liquid water. This ocean positions Enceladus as a promising candidate for hosting life, or at least creating conditions conducive to its existence. But Titan's uniqueness doesn't end there. Its surface is adorned with rivers, lakes, and seas. However, these are not Earth-like bodies of water. Instead, they're liquid reservoirs of methane and ethane, compounds associated with the metabolic processes of many organisms. This presents a potential source of energy for unique life forms that might have adapted to these frigid conditions. What adds to the intrigue is a remarkable molecule called acrylonitrile. This molecule has the potential to form stable and flexible structures, similar to cell membranes. These structures can take the shape of thin, sheet-like materials that can further mold into tiny hollow spheres known as exosomes. Just like the lipid bilayers in familiar cell membranes, these exosomes could serve as minuscule containers for storing and transporting vital substances. The excitement continues to build with the significant presence of acrylonitrile in Titan's atmosphere, detected by the ALMA Observatory. There are up to 2.8 parts per billion of these molecules swirling within Titan's air, sparking speculation that this chemical bounty might find its way down to the moon's surface over time. As NASA prepares to launch its DragonFly drone in 2027, the stage is set for an innovative mission to delve deep into the mysteries of Titan. This mission aims to shed light on the potential for life to emerge on this celestial body. In our ever-surprising solar system, tantalizing us with the prospect of new cosmic discoveries, we await the findings with bated breath, reminding us that the search for extraterrestrial life remains a thrilling journey filled with possibilities. Which of these details about Saturn did you find the most intriguing? Let us know your opinions in the comments below.